Hello everyone, welcome to another video. This video we're going to talk about just the general idea of Python, and we're going to be starting to program on Python. And here are some little introductory material that you should know about Python as well. Here we go. So today's topic, we're going to talk about Python 3. We're going to talk about the program Hello World. We're going to talk about commenting, variables and inputs, some operations, and built-in functions that can be found in Python. Just to recap, we're working with Python version 3. It is a general purpose programming language. It is an interpreted language. What that means is that when we write a Python code, the interpreter starts from the very top of our code and executes our code line by line until it reaches the end or it crashes. Next, in grade 12, we learned that Python 3 is object-oriented as well, and we get to do another programming paradigm practice with Python. But right now, it's just like a nice little a fact to know about Python. Version 3 was released in 2008, and when we create a Python file, we can call that a program or a script. Basically, you are programming when you write in Python, or you're writing a script. Let's talk about Hello World. In our previous videos, we created a simple program called printing Hello World. And basically, we used the print function and we wrote the statement of print Hello World. What it's doing, it outputs our given parameter inside the function. So a function is two-part. The label of the function, which tells us which function we're using, and inside the brackets, we can add parameters to give our function its input. So functions. In Python, there are either built-in statements or self-made statements that allow us to perform instructions based on the given parameters. So when we talk about parameters, it can be either the word parameter or a function input. When a form of data, so here the form of data is hello world, is required, a function will take it as an input. A parameter should be trapped in parentheses. Certain functions can take no parameters, certain functions can take a lot of parameters, and certain functions have that amount of parameters needed, and really depends on how you use that function or how that function was programmed. So, well, what does print do? Print is a special function. It's a built-in function as it comes with Python. You don't need to program print yourself, so that we can bring an output, a textual message output onto our interpreter. Let's talk about commenting. Commenting. So when we talk about commenting, we use a hashtag symbol or a pound symbol or a number symbol, and we can write a single comment. Comment is a way to leave human readable notes for the reader, so whoever reads your program, and we use it to explain our code and sometimes to explain what a variable does. And basically, it is a way for us to document and leave some note for whoever reads your code. The pound symbol or the hashtag is a special symbol that the interpreter will ignore that line of code. So if our Python interpreter encounters a hashtag, it will ignore that line of code and move on with the rest of the code. In programming, we need to manipulate variables. Variables hold data. We can change it. We can let it hold answers to our solutions. So variables are very important. On variables in Python, we can assign different types of built-in data type to a label, which we call a variable. So I have some numbers here. To the left, these are the labels of my variables. I have 4 variables, each with different unique label. I like to create a label that denotes or represents the data that I'm holding. So let's look at here. I have an example of a variable called numbers, and it's assigned with an equal sign to a value of 20. And that's how you read it in programming. In programming, especially in Python, when you create a variable, we create the label to the left. We use an equal sign in the middle to say that, hey, for this labeled variable, it's gonna have and contain this value. In math, when we use an equal sign, it just means that the left side is equivalent to the right side. However, in programming, when we use a single equal sign, we're saying, hey, This is a container. We're going to put this value in that container to hold. And we're following the exact same protocol in the next three variables. I have variable decimals. It is holding a value of 3.14159. We have a message variable. It's called message. It's going to contain a string or a textual value of hello. I have a variable called result, and it is holding this built-in data type called Boolean value of true. I know that you don't know what a Boolean value is yet, but I promise you we'll cover that in our next future videos. Just once again, we use singular equal signs to assign a value to a variable. And in our example, numbers equals 20 is read as variable numbers is 20, right? It contains that value. Now, for those of you who have programmed before, in Python, we do not need to specify the type of the data the variable holds. So in other languages like Java, each variable we need to specify before we even create a label that we're creating a certain type of variable. But in Python, you're allowed to create any variable and give it any data value you would like to give. Here are some naming conventions that I want you to follow when you create naming variables. Starting off with, I want you to avoid using single letters to denote a variable. I want you to avoid starting variables with numbers, because when Python reads numbers at the very beginning of a line of code, it thinks it's a numeric value, not an identifier or not a label for a variable. Your variable name should be short, but reflective of what the variables contain. So it shouldn't be vague. It shouldn't be any random strings of characters. However, it should be short and sweet and explains the value that it contains. You don't use spaces to spread out multiple words in a variable name. We practice either a camel casing or use of underscore. So in this case here, we're using camel casing, where the first word is always lowercase and the first letter of the second word is capitalized. Notice I'm following that here. For underscores, we can put an underscore between the under and the score to create the underscoring naming convention. Basically, you as a programmer will decide I like camel casing better or underscoring better, right? So, and I expect that everyone's different. Some of you will be a camel casing programmer. Some of you will be underscoring programmer. For me, I don't judge. I just wish that you follow a convention and stick to one. Next, there are a special set of keywords that are reserved for programming languages and especially Python. And those words are not allowed to be used as variable names. You can modify them a little bit, but if you spell it the exact same way as the reserved keywords, you're not allowed to use them as variables. And also, your variables should not start with capital letters. It should always start lowercase. So here are some examples of built-in keywords that are in Python that you should avoid when you're naming your variables. Your variables should not be called anything. In your early Python career, you'll see about a third of these, or even a quarter. And then the class after this, the year after this, you'll see about half. And at the end of grade 12, you'll most likely see almost 90% of this. All right, we learned that print gives us an output back on our program. But how do we give data to the program? We use the input function. So for example, I have a variable called user input. I'm following the underscoring naming convention where I'm separating the two words by an underscore rather than a single space. Then I'm assigning the result of a function called input. The input function will stop your program, and it waits until the user of the program types in anything on the keyboard to give this input function a value, not inside the parentheses here, but on the program itself. The input function can have empty parameter, as in we don't need to put anything here. However, if you put a textual message in here, we call that a prompt. We give an instruction set for the programmer or the user to follow and to know what values they should. Next, let's talk about mathematical and arithmetic operators that are available in Python. In Python, we can write code that helps us do multiple and many complex calculations that we need. And in any mathematical calculation, there are some operations that we can use, such as addition and subtraction. They still follow the exact same traditional symbols for addition and subtraction. However, when we do multiplication and division, we use an asterisk for multiplication, and we use a single slash of a forward slash for division. Now, an interesting about a Python division is that even if you divide an integer and an integer with a single division symbol, it will turn that value into a decimal value, which we call a floating point value. That's something to know, and we'll talk about that in depth later on. There is a percentile operator, which doesn't turn a number into a percentile, but rather it is a new operator denoted by a percent symbol, which we call a modulus symbol. And it is a remainder finder. When we do integer divisions, and if it's a perfect division, we have a remainder of 0. There was nothing left over when we divided the numerator by the denominator. However, not all numbers work like that. Sometimes if you divide an integer by another integer, we will have remainders. We'll have a value. We'll have an integer remainder. Therefore, if you look at this example here, if I were to do 10 divided by 3, I get 3.3333. That is because if I do 3 times 3, I get 9. And a remainder will have be 1, right? If I were to divide 10 by 3, I would get a remainder of 1. So if I ran this operation, as in I did 10 modulus of 3. So I did 10 divided by 3, and I just wanted the remainder, not the answer of the division. The modulus operator helps us grab that value and get 1. To exponentiate a value, as in you want to give it an exponent, right? We have a base, and we want to give it an exponent. So in here, this line of code, I have 10 to the exponent of 3. That gives me 1,000 because I have base of 10 and an exponent of. Lastly, there is a floor division where if I want to maintain the integrity of my data when I do integer to integer division, so if I have 10 floor divided by 3, which is just double slash 3, I get 3. It will drop the decimal and maintain a pure integer after that operation. Let's talk about built-in function. So the creators of Python were very generous for us. They created built-in functions that we don't need to program ourselves to use in our code. We can just use these built-in keyworded functions in our code so that we get to solve and do more complex problems. So here are some basic ones. Let's say I have an int function or the integer function. It will convert whatever's parameter or function input into an integer. So if I had a floating point value, it'll turn it into an integer, always rounding down. However, if you entered a non-numeric value, it will break your code and crash the program or halt the program there. And same thing with the float, it just does it in reverse. It'll convert an integer into a decimal value. If there are no decimal, just add a 0.0 at the end. And these two are what we consider a different data type. Next, I have the str, which is a string converter. It'll convert any type of parameters into a string, if possible. Next, there is a special data type called list in Python, which is just a group of multiple items, like a database of sort, and it will try to convert X into a list if possible. If you're ever confused at the data type of whatever value you're working with, you can run the type function and determine that data type is. If you have a floating point, you can use the round function to round something to the nearest integer. We have max function, which has multiple different types of parameters. So let's say if I ran a code with max comparing of A and B, it will just output the bigger value between A and B. However, if you ran max with a set of numbers or within a sequence, it will output the biggest value, the largest value in that sequence. And minimum will work in reverse. It will always output the smallest value. Lastly, we have the len function, which I like to call length function. It takes any sequence-based data types, which we'll learn later, and it'll say, hey, the length, the size, how many values does that sequence have, and it'll output a integer length for you. So today we just looked at a basic overall, I guess, tool set of what you can do with Python in the beginning, and we'll start to add on, apply these skills into multiple different examples and exercises as you go along. Thank you for watching. Stay classy.